Oh, wait. So, guys, what would change for this next question? The bounds would now go from 0 to 0.6. Because now we're stretching that spring so it's bigger. Positive. ADX. DX. I don't know the answer. Newton meters. All right, and then last one, how would this one change? What would my bounds be here? Mm-hmm. So those bounds are just representing, how much distance it's moved. Yeah. I got a 14 and a half. Okay, so, I'm not your physics teacher, I'm your calculus teacher, but I'm going to pretend I know something here. Do you guys notice that moving a shorter distance than this one took more work because the force needed to move it is more like if you think about as you pull that spring apart, it gets harder and harder and harder. You need more force behind it, or more oomph. Can I shut up now? Because you guys, yeah. Can you guys tell that this is the topic of all of the things I've taught you so far this year that I am least comfortable with? Okay. So let's go ahead and look at the next question, which is slightly more complicated. I knew you were going to ask me a question that was going to be hard for me to answer. Okay, I'm going to attempt to draw a spring here, and we're all going to be patient with me, right? That looks like a spring, right? And so here, as I move that spring, that distance is ADX, yeah? Yeah. So the distance of the spring is DX. And the force of the spring is ADX. So we are still doing force times distance. Okay. And another way of thinking it through, at least this is what, I'm hesitant to say that this is actually true, but it makes sense inside my head, is that, like, if you start thinking about it slightly dimensionally, like here we're only operating on one dimension, one length, right? Whereas here and by slightly, I mean has significant more complications. It sits on a frame, yeah.
So it's still like a cone, though.
Yeah, but the whole idea is that the bottom of the cone is at the bottom, is the vertex of the cone. That's all. All right, and I'm gonna redraw my cone just a little bit bigger. And let's see, are you with me that this is 1.5? And the height is 6. And, man, there's a lot to this. And the basic premise is that the water inside this cone is flowing over the top, right? Okay. So we have a couple of things we want to think through. The first of which is how much force is being applied right now. Okay. So the force is essentially going to be volume times... Oh, I didn't tell you this. I forgot to write this in. You guys, water weighs 9,800 Newton meters. Or newtons per cubic meter. Right, and so as we think this through, the first thing you're going to want to think through is like essentially when we're going to do an integral, that we're going to think of this as like layers of this cone, right? And so when I say volume, what's the volume of one of these layers going to be? Well, so it's almost like these layers are practically going to be a cylinder. The volume of a cone, I agree with you. But as we're doing this, we're doing a volume of just this layer, which we're going to treat like a cylinder because its height is it's a dy, it's a tiny y. Does that make sense? Okay. So the volume of a singular layer would be pi times r squared times, and if I asked you to describe the thickness of that layer, are you guys cool if I call it dy? Okay. So we already have our first problem. And that volume right now is written in two different variables, r's and y's. Do you guys catch my drift there? So that's problematic for me. So, oh man. If I were to tell you guys that the radius over the y for anyone, so like we could think of it as this little cone down here, or the big one, or any one of the cones going on here. Would you guys be comfortable with me saying that this radius is going to be 1/4 of this height? Because this triangle, and this triangle, and this triangle, they're all similar triangles. So we can say r over y has to be equivalent to 1.5 over 6. Because the angle of those triangles don't change. Are we comfortable with that idea? And if I asked you to solve that for r, we'd get r is equal to 1.5 y over 6, which I'm going to simplify to y, just 1 y over 4. So we found the volume of our layer. The volume of one layer is pi times y over 4, the quantity squared, dy. Are we good? Now, as we think that through, if I'm talking about this itty bitty layer here, how far do I have to move this itty bitty layer? If it's going all the way up over the top? 6 feet. Is it feet, meters? 6 meters. And let's go ahead and say that this is where that height is 2 meters. How far will this layer have to go? 4. And what about the halfway point? It would have to go 3. So as we start thinking through the distance we have to move each layer, how can we figure out what that is? The 6, the overall height, minus the height of whichever layer I'm talking about. Okay, so my distance is equal to 6 minus y. So I have that layer. And if my volume is pi times y over 4 the quantity squared dy, then my force is just going to be 9,800 pi. And do you guys mind if I call this y squared over 16 dy, just to make it a little bit easier? Now, so in some respects, are you guys with me that the work for just this one layer would be taking this, the force, times the distance? Is that okay? And then if I want to find all of the layers, so this one plus this one plus this one, when we're essentially adding lots and lots and lots of partitions, that would be an integral. Okay, so the work is going to equal the integral from how do I describe which partitions I'm doing? It'd be this one and this one and this one, all the way from y equals 0 to that top one would be y equals 6. So I'm going to move that layer. So my integral will be from 0 to 6. And for each of those layers, that work is going to be 9,800 pi times y squared over 16 times 6 over y, or 6 minus y dy. So we have the force times the distance, and then we integrate. Is this okay?
Like the integral on the front page says the integral of the force, but so why are we multiplying by the distance too?
Because
Because
we are. It's in this question, this dy is represents the thickness of the layer that we're pushing up. That's what we're adding together, not the. And in the previous question, the dx represents the distance because it's
getting moved.
yeah.
Okay.
The dx and the dy, like, they represent different things in per which example we're working.
Okay. So it could sometimes be of the
on 3.
Okay.
That influences things. So the ADX encompasses more.
So that 6 minus y is just specifying where we are in the cone, and then the dy is the displacement element.
I think it's the other way around.
The 6 minus y.
The dy is the thickness of the cone. The 6 minus y is how much you're displacing that particular layer.
Okay. Yeah, because the dy is in the volume equation.
Yeah.
Okay.
Guys, I got like 207,000 and some change. Does that sound about right? All right, let's go ahead and look at this real quick. How's my picture look? All right, and then I'm gonna draw a second picture to help us kind of visualize what's going on here. And that is of the y-axis. Like imagine we're looking at this tank head on because it's gonna help us understand kind of some stuff. And if the radius is 5, are you with me that I'm right here? That would be the center, would be 5, and the top of this would be 10. And then, can we figure out what is the equation of that circle? It would be
X squared plus y squared equals r squared, right?
it's sort of. If it was centered at the origin, I totally agree with you. To move it up 5, it's gonna be x squared plus y minus 5, the quantity squared, equals r squared, which is 25. And all that minus 5 does is it moves it up 5. Are we cool? And so when you think about what shape would a layer of this tank have? Not if it's laying on its side. Like, I'm going to attempt to sketch one in here and not mess it up. Wouldn't it look kind of like that? I'm saying it is a rectangle. If I took this bottle, assuming it was a cylinder and not, bottle shaped, and it's on its side, ignoring the cappy parts of it, right? If we only look at the cylinder part, the cross section of the water is in fact a rectangle. And so if I asked you guys, all right, so I have this rectangle. And so the volume of a layer of those, the height of that rectangle would be dy. Are we good with that? Okay. And
Wait, so is it like a three-dimensional rectangle?
it's technically,
Tiny three-dimensional,
yeah.
like with the height that is tiny.
It infinitely small as and approaches infinity layers. Yeah. So technically each layer is this itty bitty height that would be dy. Okay. And so the volume, I don't know if you guys remember, but for something like that, the volume would equal length times width times height. Yeah. This is describing the height. What's the length of that rectangle going to be? 10 feet. What's the width of that rectangle going to be?
Oh, is it? It's like 5, isn't it? Oh, no, it's not.
Are you guys with me? We're talking about this distance, yeah? Which is like this distance. Right here.
So it's like
It's the x distance on this circle. So what we're going to do is take this equation and solve it for x. Are you guys with me that would give me the square root of 25? And I'm just going to leave it messy because I'm just typing this into the calculator anyway. Is that okay? And technically it's plus or minus. Then the other thing I want to point out is, so the width of that rectangle, this equation gives me this distance, right? And the minus is just on the other side of this. So the width is actually going to be, the width is actually going to equal 2 times this whole thing. One, 2. I need to do both sides.
So you don't need a plus or minus anymore?
No, because it's
It's just
it's almost like you're doing the one side minus the other one. The positive minus the negative other one is 2. So if my width, so now my volume equation looks nasty.
Stacking them in here today, aren't we?
Calc 2's hard.
Oh, I hear you. So the kids that are coming out of my algebra 2 next year will either take your college credit plus or the mathematics modeling course.
Yes. I'm recording, so.
Sorry.
So my work. All right, so which layers am I adding together as y goes from? What's the height of the lowest layer? 0. What's the height of the highest layer? 10. And then if I look at this layer, whose height is y, right? Just whatever this y is. How far do I need to take up this, just this layer?
Is it 10 minus 1?
10 minus y. And then what's the force of that layer? It would be 62.4 times its volume. $24,500.
I got 245,044. I'm out of.
Double check that you did 62.4 and not 6.24.
Yeah, I did 62.4.
I got 245,000.
All right, so I put mine in wrong, right? Oh, I forgot a 10.
Oh, okay.
I didn't put the 10 part of the I didn't put this 10 in. So that would do this. Okay, I feel better now.